Okay. I should be live, as always. Requires some kind of external validation, some kind of confirmation. Hello, Zappan. Audio and video. All right. Then let us begin. Let us do what must be done. Okay. All right. So now my checklist. Press record. Press record. Colors. Colors. Ready. Pre-flight checklist. Check, check, check. Check-roo. Okay. So, this works. I'm going to jump right into the first question, and then we'll slow down again and chat. All right, here we go. Yes. I love it when it works. Okay. Alexander Sidney Oz. Why would anyone be seriously discussing fantasy like a Dyson sphere? Right. So one of the comments that I get a ton on my channel, anytime that we discuss the idea of a Dyson sphere, is some flavor of this comment that you just made. And, a sort of, obviously we can't see the eye rolling and the dismissal and the sort of deep, exasperated breath that you just made, but we know it's there. So why on Earth would we be talking about a Dyson sphere? Here we are on planet Earth. We use a fraction of the energy from the sun that falls on our planet. And we are grateful for every we are grateful for every square meter of solar panels that we have that harvests just a tiny little bit of energy. We are pathetic compared to the possible future that we might eventually accomplish. But we have seen that humanity and energy use is on an exponential curve. It's the kind of thing that grows exponentially over time. And exponentials are not a thing to turn your back on. That, the classic example is diseases. We heard a few notices about coronavirus, and then suddenly everybody's got it, and it's all around us. And that's how exponentials work. And so if you just take humanity's growth in, if you just take humanity's economic growth, just the gross domestic product, that you just follow this back all the way back to the beginning of humanity, just our increasing energy use year after year after year, that it has taken humanity, let's say 1 million years, maybe 2 million years to get to the place where we are right now today with the amount of energy use that we use. But if you just chart that exact same energy use forward into the future, then in fact, in about 1,000 years less, we will have used up all of the energy that is outputting from the star. Now you can say, well, that's ridiculous, right? That, it's exponential curves are actually S curves. You just don't know when they hit the top of the S curve. And you're exactly right. We don't know when the robot uprising, we don't know when the robot uprising is going to happen. We don't know when we will destroy ourselves. I'm sure you probably have some kind of cynical perspective that there's no way that humanity is going to last that long. And even if we do, then there's going to be some reason why we wouldn't and we don't and whatever, right? This is not a realistic perspective on the future of humanity. This is just one idea, one way to possibly search for evidence of extraterrestrials out there, that maybe there could be some civilization that has continued on, gone to space, surrounded their star with ever more satellites that are they're blocking the light that's coming from the star out into space. And every single one of those satellites that you put up there then turns from a visible light source to an infrared light source. That instead of you seeing directly the surface of the star, you are seeing the radiation that is coming from the satellite that is orbiting around the star and then re-emitting that radiation in infrared light. and that we have already begun this, right? We've already begun the construction of our Dyson sphere, James Webb, Hubble Space Telescope, the International Space Station, anything that harvests energy from the sun and then uses it to do work and then radiates the heat away in infrared is part of a Dyson sphere. Now, it is one tiny little fraction, obviously, of when you imagine the total volume that would be encapsulated inside a Dyson sphere. But it is a thing we have already begun to do. And again, wherever our S curve ends, that is when we perish, right? That's when we stop growing, we stop using new energy. Or we decide that we're too cool for increased energy use, and we decide to live in perfect, peaceful harmony with the cosmos. Who knows? And so we have no evidence that there are aliens out there. And so right now we're in the let's try every single idea. And it's weird because, we'll talk about how scientists are looking for life as we know it. That, we know that life requires liquid water and requires, and uses various organic elements, chemicals, puts them together, you get life, right? You need water as a solvent, you need some kind of energy, and you need the raw chemicals and material. And then whenever we say, well, let's look in Enceladus, let's look on Mars, people say, well, wait, why are you... Whenever we say, let's look on Enceladus, let's look under the... Wow. I should not eat dinner very close to when I do the show. All right. So when we think about searching for life in the solar system, let's go look in Enceladus. Let's look under the regolith on Mars. That these are the places that could have liquid water, could have energy, could have access to these organic chemicals. Let's look there. People will say, wait a minute, why are you looking for life as we know it? Why haven't you even considered looking for life as we don't know it? Well, obviously, let's look for life as we don't know it. And so back to the Dyson spheres, which is right now we have no evidence, so let's try every single idea. And searching for Dyson spheres are actually one of the easiest things that we can do. We have the telescopes. They are just infrared sources. You're looking for a thing that is putting out a lot of infrared radiation at a point source, something that is very small and yet putting out an enormous amount of infrared radiation. That's a very weird object. That is not the kind of thing that you would expect to see. There are a few things that kind of look like Dyson spheres, but they're actually galaxies that are really, really far away, and they're highly redshifted, and they've got a lot of dust around their center. But in general, if you see something in the Milky Way that is point source and yet is putting out infrared radiation, it is unusual and it is worthy of further study. And so why do we think about Dyson spheres? Because that's just one way to look for evidence of aliens out there. And if there are no aliens out there, then we won't turn up any Dyson spheres. But if there are some, then we will find them, if that's the thing that they create. And then the other thing is that if you can sort of take that idea of an advanced civilization, then goes on to colonize their entire galaxy, right? Again, who knows if they do this? We don't know. Maybe, right? Let's just consider, let's entertain the possibility that that's a thing that can happen, as opposed to just making up your mind that everything is impossible. Instead, let's consider that things that we think are difficult but aren't violating the laws of physics are still possible and could happen. Well, then you would imagine an advanced civilization, one that's had 1 billion years to explore its home galaxy, would... If making Dyson spheres is a good strategy, it makes sense, then they would cover a lot of their stars in Dyson spheres. And then we would see an entire galaxy, which is weird and glowing in the infrared. And again, very easy to find. That, these things, we search for them, not because they are like certain to happen, but it's because they are easy to find. We look for apples on the apple tree. We look for apples in the grocery store, right? So that's why. That it is we see growing energy use on Earth by humanity. We can predict into the future, if that growth continues, what the future of our energy use might look like. We can come up with a criteria for how we would search for that thing around other stars. And so why not try using the existing telescopes and the techniques that have already been developed? Why not? It doesn't require an entirely new kind of telescope. It doesn't require a new thought paradigm. It doesn't require investment in billions of dollars. It is the kind of thing that can be done by a grad student at the drop of a hat. And many have. And no one's found one yet, but it doesn't mean they're out there. So No one is saying that is serious, but why not look? Okay, welcome to our weekly live question show where I'm going to answer your questions about space and or astronomy. We've got a bunch of questions that have already come in, and go ahead and put more questions in if you want. I've got a database sitting in front of me that I'll be able to see all of the questions that you're asking, and I will be able to highlight them and feature them in the show as we go through this. Yeah. So, a few ground rules. First up, keep in mind that I am a journalist, not an astronomer. And so if you have questions about my opinion on various theories, string theory, so on, I cannot provide them to you. I can merely provide you my summary of the scientific consensus. I try to give emphasis to the people who've never had their question answered before. So go ahead. Get out of your shell, ask some questions. It'll be fun. And then, of course, we get a lot of the same questions. In fact, we just released the black hole, the 300 black hole questions that we've gotten. And there's a lot of overlap in there. So if I don't know the answer, or if it feels like it's a question that we've covered quite a bit, then I may skip it. And then don't ask your question multiple times. We've got it. Your question is right there in front of me. And so you don't need to ask it multiple times. Okay. Let's get cracking. Santiago T75. Would it be possible for the sun to be orbiting another star and perhaps we haven't noticed it yet due to the sheer cosmic scales and distances? So this is an idea that people have had in the past, that the sun was in orbit, a very wide binary with some other star. And we see these wide binaries out there in the cosmos. They can be tens of thousands of astronomical units apart from one another. And it's kind of surprising how faint a red dwarf star or even a brown dwarf would be in the sky. That, the closest star to us is Proxima Centauri, and yet you can't see it with your eyes. If you walk outside, you cannot see the closest star to us. You can see Alpha Centauri, it's very bright, but you can't see Proxima Centauri. And it's a red dwarf star that you would need a small telescope or, a good pair of binoculars to actually pick it out. And then that's all you could pretty much see with your small telescope. There aren't many red dwarfs that you'd be able to see because they are so faint, and you can't see any brown dwarfs. Now, there's a couple of tools that have come along who have been able to sort of give us a firm answer on this question. The first one is the WISE telescope. And this was a space telescope that was launched, 15 years ago, and it was doing a wide infrared survey of the sky, looking for things that are bright, glowing in the infrared spectrum, but not necessarily bright in the visible spectrum. And so, it's looked at all kinds of things, but one of the specific targets that astronomers were looking at is, are there any giant planets like Jupiter's in the outer solar system, and are there any brown dwarfs in our vicinity that are in orbit around us? There's this classic idea of this nemesis, right, or planet X, that what if there is a some other companion object to the solar system that's on this really wide binary orbit and comes back every few million years and devastates the Earth because its gravity messes with the Oort cloud. And so the WISE telescope was able to rule out, literally, if there was a brown dwarf in our vicinity that was interacting with us, then it would have been detected by the WISE instrument, and it wasn't. So, and we know that it actually ruled out Jupiter-sized worlds within about 10,000 astronomical units of us, which is really far. Say a quarter of the way to Proxima Centauri. So we now kind of know that there are no giant planets in the outer solar system. And so that's why when you think about, say, Planet 9, it has constraints about how big it can be. It has to be sort of Earth-sized, maybe Neptune-sized, but if it's Earth-sized, it can be closer. If it's Neptune-sized, it has to be a little farther, because those are the constraints that WISE has already set. And if there was like some future infrared survey that was done of the sky, then we could set those constraints even tighter. So that's the first tool, is WISE. The second tool is Gaia. And this was, my favorite mission recently, up until Vera Rubin came online. And this is the European Space Agency's mission to chart the positions and the movements of about 1 billion stars in the Milky Way, including especially all the ones that are nearby. And so we have incredible motion data. Just to give you sort of a sense of the capability of the Gaia mission, it could measure the position of a star to the width of a human hair seen at 1,000 kilometers. Like, just let that sink in. You take a human hair, you take it 1,000 kilometers away, and then that's the resolution that Gaia can provide. And so it knows with exquisite precision the movement of all of the stars that are in our vicinity, and none of them appear to be in orbit around us. In fact, what Gaia did was it found probably some of the siblings that the sun formed with, that it actually detected stars that have the same kind of movement through the Milky Way as the sun and the solar system does, and has similar chemical constituents to the sun. So we are definitely not in a multiple star system, and we have the tools, we have the receipts. Zephin, did you hear the meteor impact above Vancouver? No. How cool is that? No, I didn't know that this happened. I knew one happened a couple of days ago in Europe. Christian Desalier. What do you mean when you say material must shed its angular momentum before falling into a black hole? So it's the exact same thing as orbiting around the sun. The Earth is orbiting around the sun right now. It's going 30 kilometers per second in orbit around the sun. That's why the Earth doesn't fall into the sun. It is in orbit, and so its orbital speed is a balance against the gravity that is pulling it. Was it a centripetal pseudo force outward that is balancing the force of gravity that is pulling inward. And so Earth is in perfect balance. It's going in orbit around the sun. And so when material is trying to make its way, or gets too close to a black hole, then it can join the accretion disk that is around the black hole. And this thing is spinning, right? In some cases, it is spinning very, very quickly, depending how far away it is from the actual black hole. And the black hole's gravity is what sets these orbital rates. And how does it actually fall in, right? Like that's one of the challenges that astronomers are trying to deal with. Now, there's a couple of sort of interesting things that are at play here. So these particles, they're bumping into each other, right? They're jostling around as they're going around in the accretion disk. And so what that does is that causes some particles to lose a little bit of their orbital speed. And when you lose your orbital speed, you fall closer to the thing that you're orbiting. So when a rocket is going, or when a satellite is going around the Earth, and it fires its engines in the direction that it's going, then that slows it down. And what that causes it to do is lower its orbit to get closer to the Earth. Now, in the case of the Earth, we've got the atmosphere. The closer you get to the Earth's atmosphere, then you start to burn up, right? But there is no atmosphere around the black hole. But there are tidal forces. There are, various radiation pressure. Lots of stuff is going on around the black hole. And so you need some mechanism that is causing this to happen. And there's a bunch of other mechanisms, something called the Kozai mechanism, where essentially you can actually crash like highly elliptical material that's on a very sort of sort of an orbit that is not lined up with the orbit of rotation of the thing can sort of transfer that its tilt for eccentricity and cause it to crash in. So you can have like highly elliptical comets will crash into the sun, and asteroids and things like that. And so just all the stuff is going around the black hole really quickly. It's got to shed that momentum before it can finally go into the black hole. And, you know, for the longest time, there was a big issue with supermassive black holes called the final parsec problem, which is like, you've got lots of material that's going around the black hole, but it's like, what puts it into orbit and allows it to actually make its way all the way down into the black hole. That's sort of another idea about this is we always talk about the sun is the hardest place in the solar system to get to, which sounds really strange. You know, people always say, all you got to do is just drop things and they fall into the sun. But remember that anything that is you're dropping from the Earth has the same orbital momentum as the Earth. You know, it's going, or has the same orbital velocity as the Earth. It's going 30 kilometers per second around the sun. And so to actually make something fall into the sun, you have to cancel that 30 kilometers per second. You got to have it going 0 kilometers per second. And that requires a very powerful rocket. And so you have to give the material going around a black hole the equivalent of a very powerful rocket for it to be able to actually make it down into the black hole. Dougal, what are your thoughts on the changes applied to Artemis? So, you know, I would say like I don't have an opinion, and I'm about to give you a whole bunch of opinions. So we're seeing a lot of changes happen to the Artemis program over the last couple of weeks. We'll start with the big one, which is that originally Artemis 3 was going to be when humans set foot on the moon. And now it looks like it's going to be Artemis 4 is the one that has the humans land on the moon. Artemis 3 is going to be the one where where they test out docking between the Orion capsule and whatever is the lunar lander that's going to take the astronauts to the moon. And, you know, originally the plan was that they were going to use the SpaceX Starship as the landing system. But because of the delays of the SpaceX Starship, this has given Blue Origin some room to maneuver with their plans for building a moon landing system. And so now, whoever really kind of gets done first, is ready to deliver a lunar lander, is going to be the one who tests with the Orion capsule for Artemis 3. It's going to launch into orbit, Earth orbit. They're going to do the docking. They're going to make sure this all works properly. And then once that's done and safe, then they're going to fly to the moon and for Artemis 4 actually land on the moon. So that's big, right? Because that pushes Artemis 4 back, and then it starts to bump up against the plans for the Chinese, right? They're planning to set foot on the moon by 2030, and now you're probably looking at 2028, but come on, it's going to be a little bit later. Maybe it's 2029, maybe it's going to be 2030. So we may very well see a race down to the day on who's going to set foot on the moon first. Although obviously the Americans already did, right? So why does there need to be a race? So that's the first thing. The second thing is that there's been some changes to the actual rocket itself. So, and this is just breaking like in the last day or so, and I haven't even like dug a lot into it, but the plan is to probably exchange the upper stage. There's sort of a newly designed upper stage that was going to go into the Space Launch System, and it looks like they're swapping that out for maybe a Vulcan upper stage. So, you know, and this is just a way to try and decrease costs and still make the rocket do its primary mission. So instead of having to develop this thing custom with the various partners, you can just buy something off the shelf from United Launch Alliance. So, and I'm sure we're going to see a bunch more changes. And the heart of the problem is that it's an incredibly expensive rocket. It's a it's a $4+ billion rocket. Every time you want to launch this thing, you're going to spend $4 billion, which is really not sustainable. And then on the flip side, you have SpaceX saying, well, you don't need to spend $4 billion. You can just spend a few tens of millions on SpaceX Starship. To which NASA says, that sounds great. How's Starship doing? And they're like, well, there's some delays. We're working on it. And then at the same time, you've got Blue Origin, which is rushing as quickly as they can to get their heavy lift vehicle operating, the New Glenn. So we're in this weird time where it's very difficult for NASA to be able to move forward. It has a rocket that is really unsustainable to launch very many of these. They just can't afford with the budgets that they have to launch these things. You've got alternative platforms that are coming online, but they're just not ready yet. And yet you have this goal, this pressing goal that has to be hit about landing humans on the moon. And so something's got to give. And we're watching as reality rears its head, and people are going to have to wrestle with it. But I suspect we're going to see a lot of turbulence in the coming year. Aria's third of his name. Say we're wiped out by AI. What would Earth's new biosignatures look like? See, now you're thinking like an astronomer, right? Like this is the kind of question you say, okay, we are now developing artificial life forms, theoretically, right? We're making data, and who knows how this ends. But let's imagine it ends badly. Let's imagine that instead of us successfully navigating this, or the AI just doesn't work out and we destroy all of the computers and we don't worry about it. What if the AI is successful? What if the AI overthrows humanity? What if, right? Well, then what would you see? You make a hypothesis. You say, well, I wonder what we would see if the AI overthrew its world. Well, then you would probably see a Dyson sphere or some version of that. You would see some excess in infrared radiation coming from the environment around a star that, human beings, we are very fragile. And so going to space is a very difficult thing. We have to take our entire ecosystem with us to be able to fly to space. The robots don't. The robots are pretty much ready to go. Yeah, maybe they'll need a little bit of radiation hardening, but apart from that, they're ready to go to space. And so once they go to space, they're going to get their hands on the raw resources, the asteroids, the comets, the planets. They're going to get their hands on the energy that's coming from the star, from the sun, and then they're going to make things. And those things will absorb energy from the star, and then they will re-emit in infrared, and it will create an ever-growing infrared signature around that star. And eventually, if our telescopes are good enough and we understand what it is that we're looking at, then we might say, oh, there could be some kind of civilization at that star. We wouldn't know if it was life forms, biological life forms, or whether it was some kind of artificial life form, until we, were able to watch it farther. If we knew like how quickly this thing happened. The other thing is that you can imagine once some advanced civilization makes structures and puts them in space, that if they're lined up between you and that star, then these things are going to pass in front of the star and they're going to have a weird shape. So like a triangle or some kind of weird big space station. And that the dip in the light, as the transit, as the object is passing in front of the star from our perspective, that would be something that we could tell. And in fact, we can know that right now today. Like if we just looked at the light curve of a star as a triangle was passing in front of the star, it would give a bizarre shape to the light curve. And we would know right away that there's something unusual there and a good place for follow-up study. So unfortunately, we wouldn't know right away whether it was biological or artificial life forms that actually made these structures, but if the speed is happening, and then you can sort of imagine, there's this idea of the grabby aliens. And you talked to Robin Hanson about this idea of the grabby aliens, that while most civilizations are going to be slow, or maybe just want to stay home and just chill and relax and not be grabbing all of the universe, there will be some subset, some small group, the Borg, who are going to want to go for it and grab it all. and that you would then watch those structures that you saw. Suddenly you notice there's like 5 stars that are grouped together, and they all have weird transits, or they all have strange infrared glows around them, that there was an empire forming around that group of stars. But the crazy part about that is that it makes sort of almost as much sense to expand at the speed of light. Like once you can do this, then you start expanding at the speed of light, or almost the speed of light. And so we would detect the presence of an advanced civilization that was trying to accumulate as much material as it could in the universe moments before it arrived. We'd have like almost no notice, and then suddenly that civilization has swept past us. So, how do we know that we detect the robot civilization? Because their spaceships are here in the solar system, and they're beginning to dismantle planet Earth for their Dyson spheres. Frosty Winnipeg, can we get the 10-hour black hole show as a podcast? Yes, that is the plan. We tried uploading it to Patreon a couple of times, and Patreon just kept choking, and so it wouldn't upload and then be translated into the podcast version. So we might be stuck just uploading only the audio version. We've uploaded 5-hour podcasts to Patreon, and we know that works. So we'll probably just do that again. So if we, like tomorrow, probably, if we can't get it done, we'll just go ahead and just upload the audio and call it a day, and stop trying to make the video work 10 hours long on Patreon, because clearly no one ever expected that. It's too much. Frosty Winnipeg, is the rotation of a galaxy tied in any way to the rotation of its black hole? No. The orientation of the spin of a supermassive black hole that's at the heart of a galaxy is not connected at all to the rotation of the galaxy itself. And in fact, astronomers very recently were able to work out the orientation of the supermassive black hole at the heart of the Milky Way. I forget the exact angle, but it is not lined up perfectly with the rest of the galaxy. Now it can be, and I don't know what sort of percentage, figuring out the spin rate of a black hole, the orientation of a black hole, can be very difficult unless it's actually putting out jets of material. Once you get the jets come from the poles of the black hole, and that tells you the orientation of the black hole in the galaxy. And it often lines up with the, perpendicular to the spin of the galaxy, but it doesn't have to. Black holes are they have a sort of destiny of all their own. Ed Skeptic, if all the dark matter in the universe disappeared, what would happen to the normal matter? Oh, that's a great question. So we kind of work back from the various things in the universe. So the first thing is that we know that dark matter exists because of a series of observations. So the first observation is that you measure the rotation curve of galaxies, and they are rotating too quickly for the matter in the galaxy to hold that together by gravity alone. And so if you remove the dark matter from that galaxy, then the galaxy would have to make sense again. So it would be rotating at a speed that did not exceed the amount of mass that was in that galaxy. And you look out into the universe and you'd measure the rotation rate of every single galaxy out there, and you would say, they're all, they all rotate exactly what you would expect. I see the stars, I count the stars, I estimate the mass of the galaxy based on the stars, I estimate how quickly a galaxy should be able to rotate based on the number of stars, and that looks normal to me. So the law of gravity as we understand it here on Earth also seems to apply to galaxies that are really far away. The second observation is the paths that the stars take inside the galaxy itself. So when you think about the solar system, and you have the sun at the center, and you have the planets that are going in orbit around the solar system. The closer the planet is to the sun, the faster it goes in orbit around the sun. And then as you move farther and farther away from the sun, then their orbital speed slows down. So Mercury is like 48 kilometers per second, the Earth is 30 kilometers per second, and Neptune is like 5 kilometers per second. And that is what gravity predicts you would see. And so once again, when we look at distant galaxies and we measure the movements of the stars in the galaxy, when they're very, very close to the center of the galaxy, they do this. They move very quickly. They work as expected. But once you get a little bit far away from the galaxy, the stars all go the same speed. So instead of the closest stars going, say, I don't know, 300 kilometers per second, and then the stars farther away going 100 kilometers per second, and then when you're way out in the boondocks of the galaxy, the stars are only going 10 kilometers per second. That's not what you see. You see, in the Milky Way, for example, the stars are going like 220 kilometers per second. And they're doing that from almost at the center of the galaxy all the way out to the outskirts of the galaxy. And so if you removed all the dark matter from the galaxy, then the stars in the galaxy would behave exactly like the way the planets do in the solar system, which would be very interesting, right? So you would measure the speed. You'd be like, yeah, this is just like a galaxy is like just a great big solar system. I measure the stars, the ones that are very close to the center of the ones that are going around really quickly, they're going incredibly fast. And then the ones that are really far out, they're going very slow. And so that's what you'd see, but that's not what we see. And then there's other stuff. And I'm less specific sort of thinking about this, but essentially when you measure the concentration in the cosmic microwave background radiation, you have to have dark matter to be able to have the kinds of concentrations that you see, and there are other independent measurements that have been made for dark matter. But so, each time you removed dark matter from the equation, when you made the observation of the thing, it would behave exactly as you were expecting, right? And so that's why dark matter is this collection of observations, that you look at the spin of these galaxies and they don't move as you're predicting. You look at the movement of the stars inside these galaxies and they don't work like you're predicting. You look at the cosmic microwave background radiation and it's all messed up. And so, you look at the concentration of galaxies, the large scale structure of the universe, and it is, there's like more to it. And when you do gravitational lensing, right? Gravitational microlensing, where you look at the light of all of the stars that are really far away. When we look at it with telescopes, all of the light is slightly distorted, right? That the light is following this weird wavy pattern as it's making its way to us. And if you removed all the dark matter from the universe and you looked out into the cosmos, all of these distant galaxies would be perfect. You wouldn't detect any of this weird waviness. Everything would just be perfect and pristine, and the light would be clear, and it would not deviate at all from the path that it was taking. So the universe would look very different if you removed all the dark matter from the universe. And so the fact that we see this weird universe tells us that there is more to the universe than we understood. Keenan Mahoney, when might we be able to expect another round of NIAC interviews? It really just depends on when NASA does its new release. It's very soon. So normally they announce the phase ones in like March each year. So we're right around the corner. But I've been doing, I know that they're not branded as NIAC interviews, but I look for stuff that has a NIAC sort of bent, things that are NIAC-esque. And so a lot of the interviews that I'm doing sort of meets that same criteria. I've got an interview that I'm doing later on this week about Europe's answer to Starship, which is the thing called the RLV, which is a reusable launch vehicle. It's like a big airplane, a big jet airplane that should be able to fly to space and do multiple stages. It's a really cool idea. So I'm always looking for these kinds of cool ideas. Like the thing that makes me so excited about the NIAC awards and NASA's Innovative Advanced Concepts is they're just cool ideas almost from science fiction. But that's not the only place the cool ideas are coming from. I'm looking for cool ideas all the time. Whenever something matches my, oh, that's pretty cool, then I reach out and see if I can do an interview with them. And so there's like a shadow NIAC that I am assembling all the time on the channel. Silas Miller, are we really the only true observer of everything in the universe? That truly terrifies me. We don't know. So either we are the only advanced civilization in the universe capable of observing the cosmos, and only we know the sort of true scope and scale of the universe, or there are many civilizations out there across the cosmos and they have their versions of astronomers, which seems like a thing that you would eventually develop. And so they have their own astronomers. Now they're observing the same kinds of things that we are. They're observing planets and stars and galaxies and quasars and black holes and all this kind of stuff. But maybe they have different wavelengths of light. Maybe they, their eyes work in a different way. And so they sort of think about the universe in different ways. And maybe they've made a lot of discoveries about the fundamental nature of reality, about physics, chemistry that we haven't made yet. Just because, we come at our discovery and our science from a very specific perspective. I just finished reading Children of Time by Adrian Tchaikovsky, and he sort of has this, the protagonists of the book are spiders, and humans. And the spiders are advanced and intelligent and eventually develop astronomers and technology and radio and all this kind of stuff. But it's all very spider based. So they think in terms of webs. They build out of certain kinds of construction materials, and they make some, mathematics comes very easy to them, while the humans have other things that they're good at. And the sort of the humans and the spiders meet and interact and realize how much they have, they're understanding reality in sort of the same way, but they have different things, different strengths that they bring to the table. So it may very well be that the different civilizations sort of perceive the universe in different ways just because of, what evolutionary pressures were out there. So, it's back to Arthur C. Clarke's famous quote, right? Either we are alone in the universe or we are not. And either possibility is equally terrifying. Terry Hardaway, how hard would it be to put the ISS into lunar orbit or even on the moon? It would cost all the money. So I did the math a couple of years ago. And the thing to always understand is that to go to the moon is not like you just drift away to the moon. The moon is at the top of this enormous gravity well, right? The Earth, think about this feeling that you have when you try to climb to the top of a mountain, right? It's exhausting. You have to, it takes a lot of energy and effort to get to the top of the mountain. Well, imagine your mountain is 500 kilometers high. That is the altitude of the International Space Station. And so when we launch stuff into space, we have to climb a mountain, 500 kilometer mountain tall, and go sideways 28,000 kilometers per hour just to be in orbit around the Earth. Well, the moon is on a further mountain. It is now a mountain that is about 400,000 kilometers tall. And so if you want to take the International Space Station, you have to lug it up that mountain. You have to carry it. You have to push it up that mountain, and that requires propellant. And so I did the math, and it depends on what you do. You use ion engines, do you use starships, or starships cheaper? Who knows? But you're looking in the cost roughly the same amount of cost that it was to build the entire International Space Station is what it would cost for you to send it up into lunar orbit. You'd have to match the investment. So you're looking at well over $100 billion in just fuel to just raise the orbit of the International Space Station. Now, if you want to land it on the moon, then the problem is that you can't do it very slowly and carefully. You have to, at some point, have a lot of rockets that are allowing you to decelerate gently onto the surface of the moon. And so you would have to launch hundreds of rockets that would be capable of carrying different parts of the space station and be able to balance the forces as it's getting closer and closer to the moon. So it would cost, again, probably the cost of building the space station in the first place. You'd be looking at hundreds of billions of dollars to have it land gently on the surface of the moon. You'd probably send up starships. You'd break open the International Space Station. You would chomp down on the different modules. You would put them inside Starship. You then refuel your Starship. Your Starship would fly to the moon. It would land on the surface of the moon. A crane would pull out the module, put it down gently on the surface of the moon. Yeah, you're still looking at hundreds of billions of dollars to try and do something like that. Soul, what are your thoughts on science being defunded? How does the science community recover? Well, I'm heartbroken. People always say like, oh, you're a Canadian, you shouldn't be commenting on what's happening in the United States. Well, I don't think science should be defunded. And so what's happening in Canada, I would be saying the same thing. And I'm hoping that if you're Americans and you're seeing your science being defunded, you would, I would hope that if you're Americans and you see Canadian science being defunded, you would say that's a bad thing. I disagree with that. I am against that. So, science is the heart of this modern society that we live in. That the fact that your teeth don't hurt all the time, the fact that you can live as long as you do, the technology that we're using to watch this episode, to communicate across vast distances, the airplanes, the food that we grow, medicine, it just goes on and on and on and on and on, right? And yet it is always so easy to then just take the science for granted and say, we did it. We've arrived at this point in human society. We don't need to spend any more on science. And of course, the problem is that science allows you to get yourself into problems as well. That we have issues with the climate, we have issues with food scarcity, the kind of technology that we use to grow all this food. We have a lot of challenges ahead of us, and probably the thing that we're going to need to be able to continue to get out of this is more science. And there's still a lot of suffering that goes on in this world, that diseases that have yet to be cured, that could be cured. And so we need more science. I can see why people think, oh, astronomy isn't worth funding, except, when there's an asteroid that's coming towards your planet. So, practically what's going to happen is you're going to get, it used to be that the United States was seen as the best place to go in the world. That if you want to be a scientist, your number one priority is to go to the United States, the best universities in the world. Then you go and work with the best companies, or you work for the best government, research institutions, and you get to do world-class science. The United States has the best science out there. And, you're seeing people take retirements, people being pushed out, people who are losing their visas, not able to study in the school. It is causing this hollowing out of science. And it's not going to be something that's going to be felt today. It's going to be something that's going to be felt 10 years from now, right? When suddenly most science papers are coming, that most of the science papers that would have been released by the United States are coming from other countries. China, Canada, Europe. Europe is not a country, I know. And that's a very hard thing to get back. It's very hard. Once you've built this sort of cutting edge, globally respected science engine, and you've sort of taken various parts of it away, it's very hard to build that trust in with the scientists who want to come over and give up years of their life to go to school and do this. And so the price is that the mantle of scientific leadership will go to other countries. And that will suck, because I think the United States is one of the greatest countries in the world, right? I'm not from there. I'm the neighbor of there, and yet I really like the United States, and I want it to succeed. I want it to succeed in the right ways, and this feels like it's taking a wrong turn to me, in my opinion, which I never provide. How does the science community recover? Well, hopefully, the direction that things have gone will be reversed, and that trust will then build again, and it will take a while. And if things continue to grow, there's still so much momentum, so much knowledge, so much expertise, so many well-meaning individuals, so many people who have so much to give in the U.S. science system that it'll take a lot to really derail it and not have it be able to get back on track at some point in the future. But if it continues on, if it's administration after administration that continues to defund it and cause sort of havoc in the scientific community, then it will eventually have a hard time recovering. But I wouldn't overly panic. Like, I think, now is the time to take action if you are concerned about the state of science, but you shouldn't feel cynical and jaded and hopeless. Right? Just speak to the representatives that you have to try and encourage them to take the right action in funding science. Space whales. How close do you think the Chinese base on the moon will be to the American base? Seems like there's a lot of benefits being close, geopolitics notwithstanding. I mean, any base on the moon is probably going to be set up near the permanently shadowed craters of the moon at the South Pole. But there's a lot of those craters, and there's plenty of places that are ideal. There are hundreds of good spots to build base, and they're going to depend on how close you want to be to the potential frozen water, how much energy you need to get, what are some interesting scientific sites that are around you, how is the safety, are there landslide risks, how easy is it to move around on the surface in the region where you want to set up. So it's not like you've got all of planet Earth to set up. You've got your areas that you can set up your moon bases on are filtered down from a large list, but it's still lots of space. So how close would they be? I mean, I would think it would be great if they were very close. If you've watched For All Mankind, the Americans and the Russians set up their bases very close to each other, like within walking distance of each other. And, that's to set up tension and conflict in the show. But I still hold that the International Space Station was one of the greatest ideas that's been had in spaceflight. That you took two enemies, the Soviet Union or the Russians and the United States, and then all the other countries in the world who participated, Canada, Japan, right, Europeans, and had them come together to build this space station in peace. And so even if people are in conflict down below, they're working together like a team, which scientists and explorers will. That if you set up one base and you had it staffed with some Chinese and some Americans and some Europeans and the occasional Canadian, they would work in harmony. It would be great. And that it would save in transportation, it would save in risk, it would be the ideal situation. And I hope that's what happens, because that's, I think that's the right play, is to build together. But politics on Earth will transcend and go to space. Shasha, wow, I didn't get how to make the 10-hour black hole video have the background music. So what happened was we made sort of two edits, two versions of that black hole, 10-hour black hole video. one which had no music and then one that had music, 2 audio tracks. And then the way this works with YouTube is you upload the video track with the one audio, and then you can upload alternative audio to that video. And so we uploaded the alternative audio track, and it's been saying rendering for like a day now. And hopefully it will get through it. If not, we'll have to cancel it and start again. I don't know why it wasn't working. And, you know, maybe a 10-hour... We're learning about the limits of what these video platforms can handle when we upload 10-hour-long videos. Terry Hardaway, gravity, gravity, gravity. Why don't we hear about galactic magnetic fields or the galactic sphere? We talk about magnetic fields all the time. You know, measuring the magnetic field around a galaxy is tricky, but it is possible. And the way it happens is actually really cool. So you have particles that are, you know, plasmas and various particles that are in space. And that we know that galaxies can have gravity fields, we know that galaxies can have magnetic fields at huge scales. And so the particles, you know, the ionized particles will align themselves in a magnetic field, and then they will emit radiation, they'll emit light that is polarized. And so you can then detect, like you use polarized glasses, you put them one way and you can see a movie through, you know, one eye. And then when you look the other way, or, you know, sorry, have you ever played with polarized lenses where you get them in a movie theater and you put like one next to the other one and then you completely block out the light, right? Because the light is polarized one way and then other light can be polarized the other way. And so they can actually measure and map the magnetic fields that are around galaxies looking at this polarized light. And it's told them a tremendous amount about the magnetic fields that are around galaxies, around stars, around black holes. The most recent images of the event from the Event Horizon Telescope were measuring the polarity of the light at the event horizon, or the shadow of the event horizon around the supermassive black holes. And so this is very, very useful because it shows you like what influence does the magnetic fields have on the flow of material, because plasma is, you know, has a charge. And so it is influenced by magnetic fields. But it, you know, in general, the problem with magnetic fields is that they can be positive and negative. So they balance out on average. And so you can have magnetic fields in one small area that are very extreme, but over larger distances, they start to kind of mess with each other. While gravity is just one direction. Gravity is just a force, inward force, right? So, so that's why you probably don't hear as much about magnetic fields. But if you come to Universe Today, we report on astronomers mapping magnetic fields all the time. And, you know, we're in this kind of new era thanks to radio telescopes. They're ideal for observing the emissions of particles, the light coming from magnetic field line induced plasma. Nunya, what sort of internet bandwidth should we expect on our moon bases? It won't be great. So the first issue is the ping times. So it takes about a little over a second, 1.3 seconds, to send a signal from the Earth to the moon. Kind of depends on where the moon is at its orbit. And so if you want to do the, you know, round trip time, 2.5 seconds for you to be able to communicate. And so you want to click on a web page, it's going to take you a couple of seconds for that web page to start to load, no matter what. But imagine you're trying to play a video game. You're trying to play some, you know, some first-person shooter, and your ping times are 2,500. That'll be brutal. You don't want that. You want 0.15, right? So the other issue is that just it requires a bigger and bigger transmitter to be able to send that great distance. But there are some new technologies that are being tested in space. The NASA's Lucy mission has a brand new communication system on board, which uses an infrared laser to transmit data back home to Earth. And they're able to achieve bandwidth speeds like broadband speeds from tens of millions of kilometers away. So we will probably have arrays of infrared lasers on the moon that are transmitting communications from the Earth, and then the reverse on Earth transmitting back up to the moon. And they'll have big, not even big. They'll have dishes. They'll have telescopes essentially that are receiving the signals from those transmitters going back and forth. And so the more bandwidth people are trying to send from the Earth to the moon, the more that they will build more and more of these receivers and transmitters on both sides. It'll be lasers for sure. What? Are you, Darren Brown, are you getting fake pop-up ads? It distracts me. Why pop-ups? Are you talking about the text that's appearing here where I'm putting the question that you asked on the screen? Like, isn't that great? So if you kind of missed the question and you can see it on the screen while I'm giving the answer, you know that this is the question that I'm providing the answer to. I misunderstand. Is this what you're talking about? Is this what's distracting? I think it's cool, but if other people don't like it, let me know. "12 ads. You've had ads that have popped up? What? Okay, hold on. Ads should be turned off. No ads. Yeah, is anybody getting ads? Yeah, no ads. Yeah, okay. So people are saying you might have like some kind of malware on your site, on your computer. Nobody else is getting ads. So, yep, nope, no ads. So I think it might just be you. Dougal, how's the reaction going with Vera Rubin data coming in? Everything going as expected so far? Yes. So I actually did an interview with one of the data brokers, which it's funny. It sounds so shady, right? I think maybe I'm thinking of like playing Mass Effect, and there's like a race in the Mass Effect game called the Shadow Brokers. Is that right? Yeah. And so when I think about data brokers, I think they're like this kind of shady thing, but no, it's very cool. So the person that I interviewed is from Noir Lab, which again sounds kind of shady, but anyway, Noir Lab, they're the people behind the Dark Energy Survey. And so, or is it the DESI survey? Anyway, but they have this system called Antares. And they've already been sharing information from various data sources, like the Zwicky Observatory and others. And so you can go to, if you search for Noir Lab Antares, that is their data brokerage system. And it's free to use, freely available. You can build a tool that plugs into their API. Now you can just get Claude. You can just vibe code a tool that plugs into their API. It's very easy to do. And then you can produce a spreadsheet that shows you all of the objects that have been detected that night. Now remember, it's 800 million. Remember that it's 800,000 objects every night. So you're going to want to put some limitations into it. Don't just grab the full fire hose. But you could say, notify me of every object that appears in the constellation of Centaurus with a magnitude of greater than 15 that I could see in my small telescope. And then you'll be hanging out, and then you'll hear a ding on your phone because that's what you've built, and you go and check it out. And then this says there's a new supernova for you to check out in Centaurus, and you go and point your telescope, and what do you know? There it is, right? These are the kinds of things that you can build right now. I've got like a bunch of ideas, and now I think I can build them because, you know, this stuff is very easy to build with these AI coding tools. But yeah, so far everything's going great. You know, it's so soon. I don't think I've seen my first paper where somebody has made any kind of announcement about what they've discovered in Vera Rubin. You know, that's the work of astronomers that takes weeks, if not months, for them to do their analysis on all of these data and come up with some kind of conclusion. So right now, it's the Wild West, that you have hundreds of thousands of objects that are being announced every single night. It is a fire hose, and astronomers are choking on the fire hose. Fraser, hi, how do you cope with what is happening? I mean, I'm going to assume that what you're talking about is the Iran war. You know, that's sort of the big thing that's happening right now. I mean, like, how do you cope? You don't. You spend a good chunk of your day with YouTube on, with various news feeds, giving you update after update after update, and you are obsessively, anxiously wondering what this holds for the future of humanity. I'm no more stable and handling this better than any of you. It's a totally anxiety inducing time for this to be around. You know, that we could be staring at a widening, like at the very best, we are going to have disruptions to our economies. That, you know, the longer that the Strait of Hormuz is shut down, the more oil prices go up, the harder it is on the entire economy, and people are suffering under this, both in Iran, both in the Gulf states. You know, people in Israel are being hit by missiles. Like, it's a nightmare across the entire area, and then people in the U.S. are suffering under the economic sort of burden of this. So I don't think this is a war that anybody really wants. And like, how do you cope? You don't. You literally don't. You just endure. And I'm a Canadian who is watching this from the television. I can't even imagine the nightmare, the horror of what it must be like to be in that region. It's so scary. And my heart goes out to anyone who is suffering and dealing with this right now. And I hope that we get a very peaceful and quick ending to this. It really, I mean, look what's happening in Ukraine, right? Remember when the war in Ukraine broke out, and we felt this same kind of anxiety. Like, is this World War III? Is this when does Russia fire its nukes? What happens? So, you know, if you're feeling overwhelmed, this is totally normal. This is the appropriate human response to this situation, which is scary. I get it. Yeah. And I have no advice for you. Like, we all got to ride this wave together, and hopefully we come out the other side having, you know, a minimum amount of repercussions for the planet. But yeah, it's scary. Kim Barron, which fictional universe would you like to live in? Bobaverse, Firefly, Star Trek, one of John Scalzi's? Probably Stargate, right? That's except for the Goa'uld, who are attempting to enslave everybody and try to destroy Earth whenever they can. But you've got these Stargates that connect all these worlds, and you can just walk through the Stargate and go to another place. That's so cool. That is my favorite. That is such a civilized way to be able to go from star to star, planet to planet. And all the planets have already been connected up by some precursor civilization. And so they're mostly safe, except for the ones that go to black holes or the ones that go to horrible desert planets. So yeah, Stargate by far. Then probably Star Trek. Like if I had to pick number 2, it would be Star Trek. Not Firefly. That sounds awful, right? Brutal. Bobiverse? No, it's just too nascent. Like they haven't sort of got everything established. But Star Trek is pretty established. So I think that would be the way that I would want to go. Gadzooks, do you have any polarized bears in your neck of the woods? Is that a thing? Am I going to look this up? Are you talking about polar bears? Because I'm thinking like the light coming off a polar bear. Does it give off polarized light? Do all bears have fur? I would believe that. No, we don't have polar bears where I live. I live on Vancouver Island, so the only bear that we have in our part of the island is black bears, and we have a lot of them. So, in fact, it's about that time when black bears start wandering through my property. And so I'll be outside and there will be a black bear just walking past. I can share pictures of black bears. I've taken tons. And they're chill. They're great. But you still have to respect the fact that is a 100 kilogram, 200 kilogram piece of muscle that can tear you apart if it really wants to. Now we do have a few grizzly bears, but they swim over in the summertime to this one little part of the island. And then at the end of the summer, they swim back to the mainland. But grizzly bears are terrifying. They're huge. They're a lot of bear. But they don't really care about you either. Black bears are scared of you mostly. Grizzly bears just ignore you unless they feel like their cubs are threatened. Polar bears hunt you. Polar bears want to eat you. Polar bears see you as just another item on the menu. And so they're the most dangerous bear in Canada by far. And so there are places where people go to watch polar bears. You can go to this place called Churchill, Manitoba, and you can ride on the back of this truck and drive around and look at polar bears. And the polar bears will come right up to the truck and stretch right out. And, oh, it's adorable. No, that thing wants to eat you. Like if it can get up and get into that truck and start to gobble you down, it will try. And people are killed and eaten by polar bears every year here in Canada. Although they're also mauled by grizzly bears occasionally, and even black bears and cougars. Yeah, we have a lot of dangerous wildlife. But most people are killed by deer, which is that they run them over on their car and the deer, causes a car accident and they die. The most dangerous animal. Squiggly Boy. Fraser, I've seen articles talking about growing crops in lunar and Martian regolith, but have there been any studies on growing them in crushed asteroid material? No, that's a great question. I have never seen a study about people who are attempting to grow plants in crushed asteroids. And we have samples. Like we don't have any samples of Mars except for the samples or the measurements that were taken by the rovers on the surface of Mars. So they know what this stuff is made out of. And then we have some Mars rocks, which I guess you can figure out what, if you crush that up, what would be the recipe that you do to make a simulated Mars regolith. And we do have samples of lunar regolith, and people have tried growing things in the lunar regolith. And we now have samples of asteroids. We have Ryugu from Hayabusa 2, and we have Bennu from OSIRIS-REx. But I don't know of anyone who said, I wonder if these will grow plants. That's a great question. I'll have to ask someone from the OSIRIS-REx mission what it would take because you can literally just go on to eBay and buy regolith simulant from the moon or Mars. But I don't think you can buy simulated asteroid regolith. But now I want to find out. Let's see. Asteroid regolith simulant. Of course you can buy asteroid regolith simulant. So a company called SRT, Space Resource Tech, sells. You can either buy carbonaceous chondrite simulate, or Orgil type for $95 to do ISRU research, or you can buy Murchison type. And how much do you get for your? It costs $95 per kilogram. So you could buy a kilogram of simulated asteroid regolith for $95 to do your research on. So you could do this. There you go. It's real. Thank you for encouraging me to go and Google that. So now I know. You can do a search, buy a kilogram, try growing some plants. Let us know how it goes. I'm sure it'll work. I'm sure it'll be fine. As long as you put some, if you don't put any nutrients into it, then the plants will germinate and then they'll die. And if you put nutrients into it, then the plants will germinate and then they will thrive based on what's in it. Because, the regolith is going to be kind of like sand. And so it really just comes down to the organic material that is in it. That's awesome, though. Thank you. That was great. Kirk Waker, deer run people over in cars in Canada. Yeah, it's crazy, this country. Testing. Have you visited Point Roberts, USA? I have not. Point Roberts, for those of you who don't know, the Canadian border runs along the 49th parallel between us and the United States. But there is this little chunk of land that is connected to the outskirts of Vancouver, that dips down below that 49th parallel, but it is disconnected from the rest of the United States. That's called Point Roberts. And so it is the United States, but it has no land access to the United States. They have to drive into Canada and then back into the US if they want to go to the rest of the US. And they have like a post office and you can have stuff shipped to Point Roberts. It's a very weird place it's not like it's a weird place, but it's weird that this exists, that they decided to keep that in the United States, but the rules are the rules. Big C799. If the universe could somehow magically answer any question, what 3 questions would you ask? Oh man, easy. Are we alone in the universe? Right? And I want specifics. Don't just say yes or no. Although if I say yes, okay, then we're alone in the universe, that gives me the answer. But if it's no, then I want details. I want specifics. Where did the universe come from? Right? Why is there something and not nothing? I would love to know the answer to that question. And then I would want to know in detail the best way to be able to fly from star system to star system. I want the plans. I want the theoretical ideal system for traveling from star system to star system. I want the design so that we can eventually build it. That's what I would like. I don't want to be able to understand it. It's not like a monkey's paw. Turkey's a little dry. Okay. Bali, what's on the new shelf? Movies. So I, like many of you, have gotten exhausted and sick of my streaming service choices and have decided that I am going to start collecting physical media again. And in the olden days, it was very expensive, but now we have garage sales and thrift stores. And so I am picking up incredible movies, collections, TV shows, things that I really love for just a couple of bucks a piece. And so I have collected, I now have about 250, closing in on 300 DVDs that I have bought, DVDs and Blu-rays, and a couple of 4Ks that I bought because I really like the movie. Like I bought the Dune movies in 4K because they just look so good. So for example, just yesterday I got this, The Right Stuff, which is very cool. It's like a 2-disc movie. So there's the movie, and then there's a whole second disc that has behind the scenes making of historical stuff about NASA on it. So then every night, Carl and I will watch like usually watch one movie, and then we'll watch a TV show. And although we haven't actually cut the streaming services off yet, like I beg her, come on, let's just cut them off. Let's just go only watching our media. And then we have the library. So you can just take stuff out from the library. And we have like 26,000 DVDs in our library system. So it's bottomless. So you don't need to be a slave to the streaming services anymore, is my feeling. The crazy part, I mentioned this in the QA this week, so you'll see this next week, but with The Right Stuff, so this movie came out, 1981, I think? Let me see. I feel like that's when it came out. 83. And so I watched this movie when I was a kid, or so I thought. And I was telling Carla, like, I don't remember any of this movie. I just remember how it ends. I remember at the last point, they say the eagle has landed. And then we watched the movie, and I'm like, okay, where's the part that I remember? And we got to the very end of the movie, and it didn't happen. I'm like, oh, I haven't seen this movie. I haven't seen The Right Stuff, which is crazy because, obviously that's in my wheelhouse. I should watch that movie. But now I have. I loved it. It was a great movie. Very long, though. 3 hours long. Ed Skeptic, how can I live forever and not get bored? Well, that's a challenge I'm willing to face. Gio Hondo, who is your favorite Star Trek captain? Oh, man, that is a killer question. Because I have to separate what I think about the captain with the show. So, like, the best Star Trek show was Deep Space Nine, but Sisko wasn't the greatest captain. I didn't love Sisko. Man, is it Pike in Strange New Worlds, or is it Jean-Luc Picard? I think it's Pike, actually. If I have to sort of think about all the captains, which one do I like the best? I think I like Christopher Pike the best in Strange New Worlds. Man, that's a brutal question. Google, how about getting some of that Regolith simulant for the shelf? That is my editor, Anton. Yeah. Yeah, all right. I'll order some... I'll do that. I will do that. I will order... Let's see, what kind of simulants can I get? I could get Lunar simulant, Martian simulant, and Asteroid. So what does it cost for Lunar simulant? $45. 120, 35, 1. You could 100 for 33. Okay, that's in bulk. Yeah, okay. All right. Yes, I will buy some. I'll buy some simulant. That sounds great. Yeah. Like meteorites, right? Hold on. Grab this one. So do this right now, or wait till we're done. But go on to eBay and do a search for meteorites. You're looking for the Campos del Cielo meteorite collection, and you can just buy meteorites. So I know I have to hide my eyes. So these are meteorites that I bought on eBay. You buy them by the kilo, and so I give them as gifts. Don't look at my eyes, phone or camera, autofocus. Let's see. Yeah, look at the meteorite. Does that work? Yeah. So I give them as gifts, and they're not very expensive. Ilya. Why is everyone on the new Star Trek's gay? So I've been thinking about how Star Trek can be Star Trek. So I've been watching the new Star Trek Academy, and spoiler alert, it's not great. No, it's terrible. But it's not terrible because you have a gay Klingon. It's terrible because it has no teeth. It's terrible because it's telling CW stories. And when you go back to watch the original Star Trek, they were telling stories of the time. You had the people with the white on one side of their face and black on the other side of the face, and they were at war, even though, they were reversed from each other. Or you had, you had the episode about the Romulans where it was a naval fight from World War II, right? They were telling stories that were related to the challenges they were facing at the time. And you had a communications officer who was black. You had a Russian who was one of the members of the crew, and they were the enemy, right? They were the greatest enemy, and yet here they were in peaceful cohabitation. And then you had a Japanese guy who was also on the crew, and then you had an alien, right? So they were taking things that were taboo at the time. They were taking things that were challenging at the time, forces that humanity was facing, and then they were dealing with it in a science fiction way that then allows you to tackle a difficult kind of intractable problem in a way that is less confronting. And so then you could do the same thing, in the Star Trek universe at the time of Star Trek Academy, you have this fracturing of the Federation because of the burn, that essentially warp drives didn't work anymore. And so all of the planets were cut off from each other for long periods of time. And then they were able to restore warp travel, and they were able to actually start moving around in the universe again. And you had these planets that had gone back to being whatever they were like, whatever they were most like. And that you were then, Star Trek Academy is this place where you can mix all these cultures together again and try to have them live up to the sort of the greatest traits of humanity, or I guess of civilizations. That these are the Federation has these values that they espouse. And yet, because for sheer necessity, all the different planets had to survive, and so they had to go to wherever they became, and they just don't even deal with that. And that would give you a ton of great stories, because essentially, here's the trick: is you tell the stories of the problems that we face today in this science fiction format, so that you can tackle them in a way that allows you to have communication, allows people to consider ideas, have conversations about things that are kind of difficult, kind of tough, right? How do you argue with your crazy uncle who doesn't believe that the moon landings happened? Well, it's not fun. It's not entertaining. You don't want to be part of that. Well, but could you tell a story that talks about people who are kind of going into information rabbit holes? And so I was thinking about this whole thing about gay, you've got a gay Klingon, you know, and he's like kind of ashamed and he's kind of quiet and he's kind of sensitive, right? No, you should have like a brigade of Klingons that are super gay, right? And they are the toughest, baddest, just, you know, they're the elite of respect from all of the other Klingons. Like they wish they could be part of these elite troopers, and that you could then deal with, like, how do we think about, you know, wasn't that Sparta? Wasn't that ancient Greece? Like these were not considered problems. And so imagine you take the toughest, but then you also make them super gay. I think that'd be cool, right? And so, you know, people are like, oh, it's not woke, you know, it's too woke. Like, man, it's not woke enough. I want it to be so woke, it's like I'm feeling disturbed. I want my science fiction to confront me. I want it to have teeth. I want it to take the kinds of feelings that I'm having about you know, peace, about the rise of technology in our world, about the growing divisions between our society, between the difference between the rich and the poor, the differences between, you know, the fact that you have all of these cultures who are now interacting online for the first time, how you can't trust what you see anymore, right? That we're at this place where people can create and invent stuff, and we have trouble knowing the difference. And or if you actually did do something, you can just say, oh, it's a deep fake. Oh, it's just AI. I didn't really do that. Right. Conspiracies, people who believe in conspiracies. There's so much going on in human society right now. And those are the stories that need to be told. And the way you take the edge off of them is you make them science fiction. It's not, you know, people being racist towards each other. It is aliens with this kind of headgear being racist to those aliens who have that kind of headgear, right? That's how you tell those stories. And so that's what I want out of my Star Trek. And, you know, when you look at Deep Space Nine was all about trauma, the trauma of an occupied people who had to lash out against their occupiers, and how does an occupier that has been sort of humiliated deal with this situation, and how do you sit in the middle of this at the same time there is an invasion that is coming from someone who's even more dangerous? Can you align these different forces together to be able to defend yourself against this bigger threat? Can you make bygones be bygones? And if you watch the stories in Deep Space Nine, they're so good. They're so good. And we're just not getting that. It is love stories, and there's occasional little glimpses of stuff that's interesting, but in general, I'm just not enjoying Starfleet Academy. Now, I'll watch it because I have to, because it's Star Trek and I love Star Trek, and so I'll watch all the episodes, but I sort of, while I watch it, I imagine, right, what could be. And Strange New Worlds, I know this is turning into a rant. You know, you did it, you caused it, right? Why is everyone gay? Strange New Worlds is kind of the campy side of Star Trek, right? And there's a place for that, and I enjoy that. But also, I think, wouldn't it be incredible if what you thought was going to be CW for Star Trek with Starfleet Academy was actually this haunting series of stories that really affects you and shows you what it's like to be young people navigating this universe for the first time when they're able to come together, and they're kind of feral, right? They all grew up in their own worlds and they don't understand each other. And yet this is a way out of that situation. And you can tell some really great stories. And so those stories have been told in other formats, and that would be great, but that's not what we got. What we got is, you know, I love you, I'm not sure I love you, and so on. So yeah. I want Star Trek to be challenging to watch. And I think when people were watching it back in the 1960s, you know, some people just loved it. Other people were like, whoa, wait a minute. You've got a white guy and a black guy kissing? Sorry, you got a white guy and a black girl kissing? That's just wrong, right? Like you want that. You want to be able to challenge those cultural norms. So yeah. Anyway, that's how I feel. I wish it was more gay. Like heated rivalry gay. Okay. Carl Lindbergh. I've always imagined a person throwing themselves into a black hole, only watching it shrink into nothing and suddenly end up at the end of time. How do you think? So this is sort of like a bit of a misunderstanding. So the way it works with a black hole is that if you watch your friend fall into a black hole, your friend will start experiencing time dilation. And from your perspective as an outside observer, you will see them slow down and slow down and slow down. And then they will essentially stop at the event horizon of the black hole. And then they will just redshift and fade away, and then they will disappear as their wavelengths are just stretched out. But you won't actually see them fall into the black hole. And so the sort of thought is, well, does that mean that they don't actually fall into the black hole? That from their perspective, they don't actually fall into the black hole? And sort of, you do experience the time dilation, that you do experience the universe speeding up outside of your perspective, but you also experience the getting spaghettified by the black hole in real time to you. You don't sit there and watch the universe unfold for billions of years. You just fall in, and there's the screaming and there's the tearing, and then you're gone. And yeah, you might have out of the corner of your eye noticed that galaxies are living and dying around you, but it doesn't matter because you're gone. So you do fall in and you do go away. And part of it is that the black hole event horizon grows to accumulate, to include your mass. And so your death happens in a finite amount of time to you. It just appears from an outside observer to take a very long time. Now I've got a whole bunch of Star Trek questions. Moving on. Okay. All right. Does Fraser review polls? I wonder which star captain would be ranked the highest. All right, let's do it. Let's do it. Start a poll. Captain. My captain. All right. So let's see. We got Kirk. We got, move through this in order. So we got Janeway. Oh, I guess we got Picard. We've got Cisco. We got Janeway. We got, I don't even remember his name. Oh, that's all I got. I only get 4. Okay. Uh-oh. I can only do 4? This is a nightmare. No, Archer. That's right. Yeah, Archer. Okay. Can I add another poll at the same time? Nope. Oh, this is terrible. Okay, hold on. All right, we're going to have to do like a round robin then. Okay, Picard won by a landslide. Fine. Okay, so we'll end that poll. All right, so now we're going to go Archer. We got Pike. We've got, what's her name from Discovery? Michael. Burnham. And then the new one from Academy. Dagamy. Aki. See, I don't even know her name. I'm a monster. There, that's her name. Okay. Whoa. Archer and Pike. Neck and neck. There's no clear winner here. Mirror Universe Lorca was the best. Yeah, that's true. Oh, this is terrible. I thought we could just wrap this up. Okay, fine. All right. So we got Pike, Archer. Okay, we'll do Picard against Pike and Archer. And then just to be silly, we'll add Ed Mercer as well. Okay, Archer seems to... Okay, we'll do this. All right. All right, so we got Archer. Man. Okay. All right, here we go. Picard. Kirk. No, wait. Archer. Pike. And Mercer from the Orville. Because he's kind of Starfleet adjacent as well. All right. Wow. Okay. All right. I think it's like it's such a landslide. It doesn't even matter. Picard for the win. All right. Okay, fine. I'm wrong. Or am I? Now I just got to keep putting up captains. Okay. Ion Drive. Did you like the animated series? Yeah, it was fine. I had the comic books, actually. So that's how I was originally exposed to the animated series was I read the comic books. And then later on, I saw the animated series. Let's see. Thanks for the recommendation. That was fun, Dean. Dougal, did we do it? Did we save the daylight? We did. We just experienced in British Columbia our final daylight savings time switch. So we are now locked in on daylight savings time forever. And although this is bad for me as a morning person, I have less morning and more evening, which is bad for wanting to do astronomy. I will still take this over having to switch back and forth. That's weird. Didn't that get answered? Weird. Okay. Sorry, just looking at the questions. This is why we edit these. Okay. Man, we got through a lot of them. Still a lot of questions, though. Sorry. I always apologize. What time is it? Okay. Chris is saying, congratulations, Vancouver, for freeing yourself from the oppression of daylight savings time. No, we double down. We're permanent daylight savings time. We can never escape from daylight savings time now. Hmm. Chris, the one true Chris Fraser, can I ask you for your advice to aspiring journalists? Absolutely, but you have to like ask the question. Teen Kovacs, so you're staying at the incorrect time. Yeah, we are locked in at the 1 hour offset. Whoa, I haven't even thought about the implications of this. Wait a second. So sometimes we're going to be an hour behind the people in mountain time, and other times we're going to be the same time. Sometimes we're going to be 3 hours behind Eastern time, and then other times we're going to be... No, I don't like this at all. Wait a minute. Everyone's got to change with us. This is terrible. Now I've got to calculate. Sometimes I'm sure the people in Europe and UK are going, yeah, welcome to our life. Oh, this is terrible. Yeah. Yeah. So I'm constantly having to be... So this is just like, I'm now just realizing the horror of this, which is that up until this point, all of North America, we switched back and forth between daylight savings time and standard time. And now we're locked in on daylight savings time so that when the rest of North America switches back to standard time, we now have to calculate different time zones for everybody else. Oh, this is worse. I take it back. Oh, my daylight savings time back. Oh, this is bad. Okay. Okay. Chris, the one true Chris. As an American journalism student considering studying abroad in Canada next year, which Canadian colleges would you recommend? I have no recommendations for Canadian colleges. My experience in Canadian colleges is 30 years old. So I went to UBC in 1989 and would have graduated in 93, but then I left. So, and at the time, the best university here was, I think, Simon Fraser University, and now the best university in British Columbia is definitely UBC. It's one of the best in the country, but there's a bunch. So, I have thoughts about going to school to be a journalist. That we sort of live in this, like, I didn't get any training to be a journalist. I just started journalisting, reporting. That there's, because we can report on the internet, we can sort of Substack, we can find out information and we can share it, learn to write, podcast, do video. I have people on our team who I've talked out of going to journalism school because they're already journalists. What do you need? Right. So yeah, I would, if you want to be, like, it's going to be a really hard time to be a journalist shortly. It's already a hard time to be a journalist. The industry is compressing and contracting. There's a lot less jobs to go around. We figured out a solution for Universe Today. thanks to the patrons. So we're safe and we're stable forever. But it's still carnage out there in traditional media companies, and will be for a while. And then at the same time, there are plenty of journalists who are making a career just by being a solo reporter, and that's kind of incredible. So, yeah, it's a tricky time to try and be a journalist, and especially to spend money going to university to be a journalist. Um, Bruce Leenstra, what our Jones said, pick a Canadian college and plug them until they give you an honorary degree. Okay, that sounds good. Um, I'll I'll pick a university in Canada. So uh, Bob from Quirks and Quarks, he has an honorary doctorate from some university in Canada. So, if he can get one, I can get one. Carl Lindbergh, will you come to Spain in August? So there's an eclipse that's going to be visible in Spain in August. And no, I am not going to be attending this eclipse. I was invited to do a cruise that was going to be sort of off the coast of Iceland at the time. And I've just decided I just don't want to do that kind of thing. Like I turn all that stuff down now. Like if I want to go on a trip, I'm just going to go on a trip. I find that there's too many just obligations to you speak, and then I don't know, it's always a mess. And then I've had a couple of people invite me to go and hang out in Spain who live on the eclipse track, but it's going to be a mess. The 2017 and the 2024 eclipses were across the United States and, through Mexico, United States, and Canada, the big long tracks where you could pick thousands of kilometers where you wanted to go and show up, and you would, it could handle the concentration of humanity into this. But in Europe, this thing is going to cross a little bit of Iceland, and then it's going to cross this thin part of the isthmus between Spain and France. So you're going to have all of Europe trying to concentrate down into a line that's just a couple of 100 kilometers long. It's going to be a nightmare, just a nightmare. So, although I would love to see another eclipse, and I plan to, no, I don't think I would come to try and navigate to watch this one. But if you're there, if you live there and you're close, then by all means, give it a shot. Frosty Winnipeg, honorary doctorate. Isn't having an asteroid named after you the same thing? I guess so. And on that front, Pamela, my co-host at Astronomy Cast, got an asteroid named after her. So there's now an asteroid Pamela Gay, which is amazing. I felt so bad. Like, not so bad that I was going to give her my asteroid, but I did feel bad that I had an asteroid named after me and she didn't, even though she's the astronomer. But now she has an asteroid named after her as well. So, yeah. And so you could go to Vera Rubin and you could discover asteroids in the Vera Rubin data, and you could name them after things that you consider to be important. So I would think a very interesting tool to build right now is an asteroid hunter out of the Vera Rubin data networks. Just saying. Crystal One True Chris. Well, thanks for the advice. Yeah, like I don't want to dissuade you from going and being a journalist, and I don't want to dissuade you from coming to Canada for going to school. Canada's amazing. You'll love it here. right? It's a great country. And I'm sure the journalism program is going to be really interesting. And there are some really great journalism programs in Canada. Again, I have no knowledge of them. You're going to have to, talk to ChatGPT, I guess. It'll probably tell you what is considered to be the best journalism programs in Canada. And then some will have wait lists, some will be easy to get to, apply at them all. But the only thing that I'm just saying is don't wait to be a journalist. Like you don't have to wait. You can do it right now. And then still go to school. But the thing that comes first is that there's got to be something you're curious about. That's the thing that matters the most for being a journalist, in my opinion, is that there's something that drives you, something that you want to know more about, and your brain doesn't work as a scientist, right? Like I would be a terrible scientist, I think, just because I'm easily distracted. There's lots of things that I want to be able, I'm curious about too many things. And I think it would be really hard for me to sit down and like do the detailed, laborious work of actually writing science papers, of doing that kind of intricate tasks. And so being a journalist allows me to satisfy my curiosity one step removed, to go and talk to the people who are doing the work and find out what they've discovered, right? And so I think that's the way for me. And so the thing that I would want to know from you as someone who's aspiring to be a journalist is what are the stories that you want to tell? What are the kinds, if it's a science journalist, then what is the kind of science that you feel that you can help explain to the wider audience, to the general public? Because we saw with COVID, man, I should have led with this, and I apologize. We saw with COVID the need, and we see this now with climate change, that the need for people to be able to clarify and explain the nuance of science is more important. So this is the terrible irony, is that the actual professional journalistic program, or the field of journalism, the job of journalist, is being pushed to the wayside, and that there's less and less emphasis on people being journalists. And on the other side, the need is greater than it's ever been. Right? Like we have never needed science journalists more than we do right now, when there is so much disinformation and so many people who are attempting to undermine the value of expertise in modern life. It's terrible. And I do my part, and I see other people who are attempting to do their parts, and together we will try to hold the line. To go, no, science is about examining nature. Science is about probability. It's about testing your assumptions. It's about keeping an open mind. It's about, right? Like there's all of these things that science does really, really well, that the rest of society has a tricky time with. And, you told me coffee was good for me. Now you're telling me coffee is bad for me, right? No, what scientists said is that they did a study of 1,000 people, and they found that of those 1,000 people, the blood pressure in the majority of them went down more than the amount of people whose blood pressure went up. But there's other circumstances. Who knows? But maybe coffee is good for you. Maybe, but it might be bad for you. So stay tuned, right? Like that's a hard story to tell, and yet people want to know whether they can drink coffee or not. Is it safe? Right? So that people will need science, and they will need science journalism, or they will just need journalism, right? Like talk about the stories that are happening right now with the war in Iraq, with the war in Ukraine, with what's happening in the economy. There's financial journalism that needs to be done. There's look what's happening with the Epstein files, like the brutal journalism to try and get to the bottom of some of this information. This is important work that needs to be done. The problem is it's coming at a time when the actual profession is under attack. And so it requires a certain level of being part of the press has always required a certain level of kind of bravery and craziness, but it's reached kind of the next level now. So it's a challenging field. There's diminishing job prospects, but the need is there. And if you can connect to the people who need it, that there is a career to be made for sure. But it probably won't look like the career that it used to, right? It won't be that you go to journalism school, come out with a degree, get in as a reporter, as a cub reporter, at a local newspaper, then move to a larger newspaper, then move to a larger nationwide newspaper, take on bigger gigs. Like, it won't be that. It'll be something else. Like what we've done with Universe Today. Like, Universe Today is not a traditional media outlet, right? It is a collection of people who are curious about science, who write this stuff and are, and we have a certain kind of voice, and we have a certain perspective on scientific, on the scientific method, right? And it's just different. And you see other people who have Substacks and or Patreons, and they're making money from this. So yeah, there you go. All right. You tricked me into doing a longer episode, but that's fine. This is so much fun. So now I'm going to wrap this up. Thank you, everyone, for hanging out with me, as always, here on this show. I really appreciate it. I love all the questions. This is so much fun. What's coming up? So hopefully tonight we will release the interview with Lee Feinberg, who this is round 2, and he is the legendary designer behind many of the best space telescopes that have ever been made. And it's just an incredible interview. March has just begun, and this is going to be the best interview of the year. Just watch this interview. You're going to love it. And of course, we just released our 10-hour black hole collection. And of course, now we had a bunch more black hole questions this episode. So I guess we'll have to release round 2 at some point in the future, 10 years from now. So thank you, everyone. And we'll see all of you next week.